Assalamu alaikum and good morning. Today we will talk about software testing, and the topics that we will cover is development testing. What are the methods that we use to test our software being developed during development, and test-driven development, a method that combines development and testing. Release testing, on how we test every release of the developed application and how we relate it with previous releases. And then at the end, user testing. And by the way, testing is an important phase of software development because it assures that the program does what it is intended to do. All right, and it actually has two purposes. The first is to make sure that the program has been developed is doing what is intended to do, and then to discover program defects, some problems or bugs that might have been still in the software, and then the programmers were not aware about. And testing normally is done over what we call artificial data or dummy data. And then we check the results of the test and try to find whether it has any errors or anomalies, anything unusual, and the correction of the software would happen afterwards. It may reveal the presence of errors, all right, not their absence. Means we can discover if there is an error, but if there is no errors, the test will be considered as a failed test. And we will see the types of tests in a second. So we have two goals when we do testing: to demonstrate that to the developer and customers that the software meets the requirements, and to assure that the behavior of the software is correct. Actually, we could say to discover whether it is incorrect or undesirable or does not conform to the specification provided by the customers. So we have always two goals in our tests. Some of you may have heard of the term validation and verification. So validation is a method of testing. So the first goal that we have mentioned earlier leads to validation. Software meets its requirements, so we validate whether the software is doing what is intended to do. The second goal leads to defect testing, and it is successful when it finds some defects. So in validating or validation testing, we check if the software meets its requirements, and a successful test shows the system operates as intended, means it does what it was planned to do. Defect testing would discover the faults and defects in the software and behavior where the software behavior where it is incorrect or not up to the specification provided by the customer. And a successful test is a test that make the system actually perform incorrectly. So defect test is successful when we find problems in the system. This diagram actually illustrates how the tests are being delivered. It's very abstract diagram. You can see the input test data and the part of the input test data that cause problem. And when we apply this data through on the system, we are supposed to get an output test result, and part of this result should be an output or includes errors, and we refer to it as OE in this diagram. And these outputs reveal the presence of defects. So a good test with wrong input would result wrong output, and this scenario considered successful if we receive a wrong output for the wrong input. Now, verification and validation are two different concepts that are usually misunderstood. Verification is to confirm if we are building the product in the right way. Validation, on the other side, are we building the right product? Means the product might be right, free of errors, but it's not the product that the customer is looking for. So to confirm whether what we have developed is actually what the customer wants is validation test. To confirm whether what we have built is built correctly according to the specifications provided by the customers is called verification test. So the validation and verification are a core part of any testing phase, and it helps to establish confidence that the system fits for the purpose it was intended to be developed for. And then it depends on the system purpose, user expectations, and marketing environment. Means the validation and verification confidence depends on those three factors: the software purpose, the user expectation, and marketing environment. So if the software is built for critical mission, the software purpose or the confidence should be much higher compared to developing a website. Again, we have one more term to discuss: inspections and testing. So software inspections are concerned about the analysis of the static system representation. Means inspection is a testing procedures that happens while the system is not running, while software testing is concerned with the exercising and observing product behavior, and we call it dynamic verification. This means we have to run the system with a certain amount of data in order to be able to detect whether what we have developed is the right product or whether we have developed the right product. So you could think about software inspection as a previous step before software testing. Software inspection, we implement the inspection procedures while the system is not running, means on the codes and libraries. And it is highly, or basically it is code analysis. While software testing, we deal with the system while it's running, and it is called dynamic verification. So inspection involves people examining the source representation with the aim of discovering anomalies and defects, and it does not require execution of the system. That's actually the core difference between inspection and testing. And it may be applied to any representation of the system. Means it could be applied to the requirements, to design, configuration data. So it could be applied to any materials related or representation related to the system, not necessarily the code itself. And it is an effective technique to discover program errors. And of course, inspection is lower in terms of cost. So inspection advantages, it help actually pre-detect errors that are not able to be detected during testing, because there are some errors that can hide other errors. So if an error shows up, it doesn't mean that it's one error. It might be more than one error. So how could we confirm that we have only one error? Through inspection. An incomplete version of systems can be inspected without additional cost, as it does not require a testing team. Inspection also can consider broader quality attributes of the program, such as compliance with standards, probability, and maintainability, again because it can apply to all system representations. However, inspection and testing are complementary and not opposing verification techniques. Means they don't overlap each other and they don't conflict with each other, so both should be used during the validation and verification process. And inspection check conformance with specification, but not conformance with customer's real requirement. And this means conformance with the specifications, because the specifications are written by the software engineers and system analysts, but customers may have a different say at the end. So it would, the checking will be according to the specifications, but it does not cover conformance with the customer's requirements. And of course, inspections cannot check non-functional characteristics such as performance and usability, simply because performance and usability requires a dynamic verification, which can be done through testing. This is a model of the software testing process, and you can see from each process we produce a certain product that we rely on at the next process. So you can see from designing test cases, we have a group of test cases, and test cases, I think we will talk about test cases in a second, but in a nutshell, test cases are instructions on testing the system doing a specific functionality. So we gather a group of test cases and then we prepare test data, because for these test cases we require data to be entered to the system. So after preparing test data, we have the test data along with test cases. Then we run the program with test data. We start giving those test data according to the cases one by one, and we test the system. Testing is giving actually test data and observing the results, and then at the end of the running the program with test data, we collect, for each run we collect a test result, and at the end of the or by the end of all test cases we will have test results. Then we compare results with the test cases that we have initially, and we try to see whether we have got the correct answers that we expected back at the test cases, or we got something else. And according to this, we write, as a test engineers, we write the test reports. Okay, in the second video we will continue on testing.